Statically definable systems and the degree of definability. This lesson number 3.1, the article 3.1 from the book Mechanical Systems Calculations of the Marine Facilities. The concept of the indefinability important to do the issues in the mechanics of the body, and we have sometimes the unnecessary variables, and we need more the equations than the equations of the balance. So the variables comes from the unnecessary connection of unnecessary for the geometric unchangeability of the mechanical system. But yeah, actually, these necessary connections are used to improve the stiffness and the shape of the mechanical structures. Yes, but to make it more complex, the determination of the support reactions, one of two issues of the statics in the mechanics, due to the issues are first is finding the support reaction, second is drawing up the balance equation for the mechanical system and its elements. So the degree of inchangeability is equal to minus of the degree of geometric freedom of the mechanical system, of degree of freedom of the mechanical system. So the static indefinability or determinability of static can be external and internal. First of all, about the external static indefinability, look please on the figure 3.1.1a. We have a frame on the embedding A, and we can fix it hinge B, two supports of the frame. Embedding we can transform to elementary supports, support rods, and here we have we must have at least 3 support rods, because we have 3 variables, 3 elementary support rods in the hinge A, not in the hinge, in the embedding A, to make the support reactions of the force of support reaction and the rotating moment in the hinge in the support A. In the support B, we have the reaction force and its 2 components, HB, the horizontal component, the projection of the reaction force on the abscissa axis, and the vertical component of the support reaction at the point B. So together we have 1, 2, 3, 4, 5 efforts of the support of the considered frame. But we have only 3 balance equations, so we know this number of the balance equation not enough to determine all the support reactions. So this frame is 2 times statically indefinable. The degree of freedom is -2, so the degree of static indefinability of this frame with the supports is 2, and the degree of the freedom of this mechanical freedom of this frame is -2. So this is external indefinability of the frame. Besides of that, we have the internal sometimes of the indefinability of the mechanical system. Could be the example on the figure 2.1.1, 3.1.1. We have the frame. This frame have 2 supports, and the fixed hinge A and the sliding hinge B is a fixed hinge. We can substitute by 2 simple supporting links, supporting rods. The hinge B is only 1 supporting rod we have. Yeah, and we have 3 variable of the support reaction. So this in the support A, we have 2 variables HA and VA. which are the component of the force in the support A, and in the support B we have only one vertical component due to the sliding hitch do not give us the horizontal component of force, only the vertical one. Okay, so we have three, and we have three equations of the balance. So actually, we can find all support reactions. But here we have the closing loop. This one contour is closing loop, unhinged with no hinges inside the closed loop. This closed loop usually have the degree of internal indefinability 3. For example, we can use a section method, like a method Ritter maybe. If we will sect this loop into two parts by any like a line, or this is a flat state, so this is on the plane, so we can use any kind of the line here, and the connections in the cut of part we can substitute by the longitudinal force, the transverse force, and dependent moment for each cut rod. As here, for the example, as well for the second one rod, we have as well three unknown efforts inside of the rod is internal static indefinability for this loop. This is a closed unhinged loop, and to find 6 efforts inside of the elements of the loop, we have to have 3 excuse me, 6 balance equations, as we have 3 unknown for each of cut rod. As for this one is the same as for load one, down one rod. We have to, in each we have 3 unknowns, as longitudinal force, as transverse force, and the rotating moment, bending moment for each of the rod. But we cannot these 3 and here 3 and here 3 unknown efforts. But we have only 3 balance equations. So this loop is 3 times statically indefinable. So what is degree of static indefinability of this considered mechanical system? It consists of 4 disks. We can use a formula maybe of Chebyshev, this like the factor 3 multiplied by the number of the disks. The number disk is an unchangeable part of the mechanical system. Therefore, sum on the second is minus 2 multiplied by TT is a number of the simple hinges in the mechanical system, minus C0 is a number of simple supporting links. So first of all, about disks, we have 4 disks here. So each disk have 3 degrees of freedom. So one disk is from the A, this corner, is a rigid corner to this point. Another one is from this point to the another one hinge in the right one stay here. We have this rod between 2 hinges. This is a simple hinge, this simple hinge. This is double hinge because it connects 3 rods. So 2 rods connect to the previous one. If we consider this as the first one, or this is the first one rod, so 2 hinges connected to him, 2 rods connected to him. There's this double hinge. It is like the equivalent of 2 simple hinges. I mean, as when we appreciate the degree of geometric freedom. Okay, and we have the embeddings as the supports A and B. So each embedding is equivalent to 3 simple links, and which give us these 3 supporting links in each embedding give us the 2 components of force and 1 component of the bending moment, rotating moment at the embedding at A and B. So we have 4 disks, each with a degree of freedom 3. We have 4 hinges. Why 4? We have 1, 2, 3, but there's a double hinge. So actually we consider this as the 2 hinges. So we have 4 hinges, which is each is of the 2 degree of freedom. And we have 6 supporting links. These 2 embeddings each satisfies 3 supporting links. It's 2 satisfies for 6. So the number of degrees of freedom of this right one mechanical system due to the Chebyshev formula is -2, and the degree of static indefinability is minus degree of geometric freedom, and it is 2 degree of static indefinability of this mechanical system. These examples of degree of indefinability for the system indicated on the figure 3.1.2. It's just a truss. The truss have 9 rods and 6 hinges, and this truss have the support 3 supports. One support A, another one B, and the intermediate support, the A support, is fixed hinge, and this corresponds to 2 simple supporting links. The support B is the same, is a fixed hinge with the equivalent of 2 supporting links, and this is the sliding hinge support here. And what is degree of the freedom of this this truss? Degree of freedom, we can use a formula of Chebyshev maybe. Is this equal to product 3 by number of disks? We have 9. Each the rod is disk, so is unchangeable part of the mechanical system is the rod for the truss. So we have 9 disks minus 2 multiplied by brackets. In the brackets we have the number of the hinges. We have only 2 simple hinges, A and B, simple hinges. We have 3 double hinges. The hinges this one, this, and this. We have double hinges, the 3 double hinges. Each of the double hinge connect 2 of rods to another one. So it is equivalent, each double hinge equivalent to 2 simple hinges. And we have one 4-time hinge. This 4-time hinge is over here for the sliding support. And we have simple supporting links 5 for the fixed hinges. We have 1, 2, 3, 4, 5, yeah. And finally, we have the, by use of Chebyshev formula, we have the degree of freedom of this mechanical system is -2. That's why as degree of static unchangeability or indefinability is minus degree of freedom, geometric freedom of this truss, and equal to. Besides of that, we can have the formula more frequently used for trusses as the first summand is not the calculation of number of the total degree of freedom of all disks within the mechanical system, but we have the first summand as a number of the degree of freedom of all nodes of the mechanical system, of all hinges. We have 6 nodes. 1, 2, 3, 4, 5, 6 nodes. So 2 multiplied by 6 minus number of the links between nodes, and the links are rods. So 1, 2, 3, 4, 5, etc. 9 minus number of the supporting elementary supporting links. We have 5. So finally, we have the degree of freedom by the formula of the not Chebyshev, but another one with for summand of the assess of degree of freedom of all nodes, and we have that the same degree of freedom as we got here before, but Chebyshev formula -2, and the number of the number of degree of freedom is -2, and the degree of static indefinability is just 2 of this mechanical system. We can do any change in the mechanical system, considering here, we can install the extra rods here, but we will remove two supporting links here, from here and from here. There is not here. Have no intermediate supporting links, and the right one support is just the sliding hinge. But we install in the frame itself two diagonal rods, and when we can do change in the last one formula, the number of rods will be no 9 but 11, and the number of the supports will be no 5 but 3, and we have the same after the done change of the structure of the considered mechanical system. We have finally a -2 degree of geometric freedom, number of the geometric freedom, and we have as well the degree of static indefinability have to be 2. Yes, and we next can put one more supporting links exactly, and so it is a subject for the research, and if we put the supporting links, we can change the degree of static indefinability of the mechanical system. So for mechanical system indicated on the figure 3.1.3, we did consider this one originally. This is 3.1.1 C mechanical system. We have 1, 2, 3, 4 disks. Due to the Chebyshev formula, we got that the degree of mechanical geometric changeability is -2, and degree of static indefinability is 2, equal to minus of degree of geometric freedom. And could we use Chebyshev formula for another mechanical system, like for the indicated on the shown on the figure 3.1.3b, this one? Sometimes we cannot, because if we will use the Chebyshev formula for this one, mechanical system is a frame on 2 supports. First, we will decide that perhaps this frame is statically definable. Why? Because when we substitute this all rods here, all frame, we can consider as a disk. We will have only one disk with 3 degrees of freedom, and we will we have no hinges inside here, so the second summand will be 0, and the last one will be 3, as well as we have 3, 1, 2, 3 supporting. So it will be 0, and the degree of static indefinability will be 0. So from the point of view of Chebyshev approach, this could be the statically decided as statically definable. But we can consider that we have here the hinge-less closed mechanical system, like a closed contour or closed loop here inside. This closed contour usually have internal static indefinability. Internal static indefinability of closed contour is usually equal to 3, because if we do section here, these 2 links in this closed contour, we will have, instead of the cutoff part, we have, for each rest part, we will have 6 unknown variables, 6 efforts, 3 in the one rod and 3 in another one rod. And to do the determination of this system, we have to have at least 6 balance equations, but we have only 3 on the plane. We consider the flat state. So the system is statically indefinable, but we cannot use the Chebyshev formula. Is internally statically indefinable. And we can assume that here we have -3 degree of static indefinability for the system, but it is internal static indefinability other than the external static indefinability. In the external approach, this system, we can say, is statically definable. Statically definable as we have 3 support actions and 3 balance equations. So The degree of internal static indefinability of a frame with closed loops is related to the number of closed loops. So we closed loops or closed contour. We had the formula as each the degree of static indefinability we can find as the product 3 factored by k number of the closed loops within this mechanical system. Where's loops here? Closed loop is obvious with the up between the rods in the upper part of the considered frame is one loop. Another one loop, we have to consider the lower part of the frame, but taken together with the support ground. So this is a part of the mechanical system when we consider the formula for determination of the static indefinability by the number of the closed loops. We consider the loops not only within the frame itself, but between the frame and the ground and the support. So another one closed loop, and we have very small loop here. So the fixed hinge is a closed loop too, but if there will be here will be I just assume the embedding for 3 variables, and we can substitute this embedding by 3 simple supporting links. Now there will be not one small closed loop here in the support A, but here will be 2 closed loops. And just keep considering the example of the frame B. And minus TC, total number of simple hinges. Total number of simple hinges. How many simple hinges we have? For use of the formula for the closed loops, we have to consider not only the hinges belongs to the mechanical system, like a hinge A and hinge B, but we consider the hinges belong to the other part of mechanical system as the ground, as a support belongs to mechanical system in the sense of the closed loop concept. So we have 1, 2, 3, 4. We have 1, 2, 3, 4 simple hinges, but we have a point of the connection of 3 hinges is a simple links, which are substitute for the fixed hinge A in the assigned mechanical system, and this hinge A have to be double hinge. So 1, 2, 3, 4, and this double hinge we can assume as 2 hinges in the point A. So together 6. 1, 2 simple hinges, 3 connecting just only 2 disks, 2 pieces of the mechanical system, and this hinge connecting 3 pieces, the rod and the 2 simple links, supporting links in the point A. So the degree of static indefinability for the considered frame first got that the frame statically definable from the external point of view due to the we have enough balance equations to determine all support reactions of this frame. But from the internal point of view, the system statically indefinable, and the degree of static indefinability, as each consists of closed loops, the degree of statically indefinability is equal 3. Actually, we can understand easy as when we do the section method for the one of the closed loop, and we see that we have 6 reactions within the cutoff part of the system in the rods, but for the 6 we have only 3 balance equations and not enough. Okay, we need to, so we have 3 unnecessary separation. Unnecessary from the point of view of the mechanical approach for determination of the balance of the mechanical system. But exactly these rods 2 are necessary both to improve the strength and stiffness of the mechanical system. So this is just only theoretical concept that this 3, which one, M1, N1, Q1, or M2, M2, Q2 are unnecessary. Okay. Questions and comments. Statically indefinable mechanical systems is if we have the unnecessary from the geometric point of view links to keep the system as geometrically unchangeable. That's why we have static indefinability, as we do not have enough balance equations to determine support reactions. And 3.1.2 external and internal statically indefinable systems. Some systems can be external, statically indefinable, but only if they do not contain the closed and hinged contours as mechanical loops. But if they are, perhaps they are statically indefinable in the internal approach. And to use for the external determination, static indefinability of the mechanical system, we have to use perhaps the formula of Chebyshev. The first summoned in the formula is the account of the degree of geometric freedom of all disk unchangeable parts of mechanical system, and etc. The number of the simple hinges connecting these disks and number of simple supporting links, or the formula usually used for trusses with the first summand as the account of the number of the hinges of the truss, and the next summands are the number of rods in the truss and number of the simple supporting links as well. This is for determination of the external static indefinability and or the geometric freedom of the degree of number of the mechanical freedom of the system. And for the internal static indefinability determination, this is likely to use the formula on the basis of the number of the unhinged closed loops within the mechanical system, attributing to the loops not only the loops within closed unhinged loops not only inside the mechanical system itself, but as well the loops, part of which is the mechanical system. Another part could be the support, like a ground. 3.1.4 determination of the numbers of degrees of freedom on mechanical system by Chebyshev formula. The most important difference of other formulas is that the first summand in the Chebyshev formula is the account of degrees of the geometric freedom of the disks, unchangeable parts of mechanical system. They as well account the number of degrees of freedom of the links between, or simple links between disks, and account the number of the freedom of the supporting links, simple supporting links. Static indefinability of a truss, we can find the static indefinability due to each is equal minus the number of the degrees of freedom, geometric freedom of truss. So we can use the formula for defining the degree of geometric freedom of truss. The degrees of geometric freedom of truss, the first summand is differ with the Chebyshev formula for other mechanical systems and trusses as well, but as well for frames. But for the truss, we can use first summand as the number of degrees of freedom of truss nodes. And as well, we account in the formula for finding of geometric freedom of truss, the number of the rods within the truss and number of simple supporting links in the truss, simple supporting rods in the truss. And the degree of static indefinability of truss will be minus the number or degree of geometric freedom of truss. 3.1.6 finding the number of degrees of freedom and static indefinability of the truss as a mechanical system using Chebyshev formula. Yeah, just for any mechanical system, but we can find the disks within a truss. Usually we can consider that the disks within truss are the rods in truss, unchangeable element of truss. They do not, they are not under the influence of the bending moments, only the longitudinal forces in the truss due to the hinges do not transmit the bending moments and the transverse forces as well, just on longitudinal forces and trusses. 3.1.7, the closed contour, internal static indefinability of the frame. Closed contour is the space, could be the area between the mechanical system and the support. Or within this mechanical system, closed contour with no hinges usually is important for determination of the degree of static indefinability for the mechanical system with closed contour that these contours do not contain the hinges. And the contour as well, we have to consider between the mechanical system itself and the support. As well, we consider the closed contours within the substitute of the supports. If you substitute by simple links, which are substitute of the support of the mechanical system, this simple links as well form the support the closed contour as well. So we count this closed contour as well of the simple supporting links to in the supports. Thank you very much.